Now present topic is Fraunhofer diffraction due to the double slit. Here the experimental arrangement of double slit experiment. Here we can see the source of the light and two slits S1 and S2 and a screen YX, and similar to single slit diffraction, here also two convex lenses are arranged in this experiment. And when light rays reach it to position O, then we will get the maximum intensity. We can also call principal maxima. When two rays, for example S1P and S2P, reach it to at position or point P, then we will get the some path difference between the S1P and S2P. Then we will get the diffraction pattern at P. S1P and S2P has same phase and with some phase difference, that is the S2K. S1K is the normal line draw to the on S2 and P. Now we have to find the S2K, that is the path difference between these two rays S1P and S2P. For that we draw a triangle S1 and S2K. Here sin theta is equal to S2K by S1K. Here S2K is the path difference, then we have to calculate that one, that is equal to S2K by E plus D. S1K is equal to E plus D, that is the distance slit width and the distance between the two slits, that is total S1K is equal to E plus D. Path difference S2K is equal to, from this equation, E plus D sin theta. Corresponding phase difference delta is equal to 2 pi E plus D sin theta by lambda, that is equal to 2 beta. Here each slit produces a diffracted light of amplitude, that is equal to A sin alpha by alpha. Here alpha is equal to pi E sin theta by lambda. Intensity calculations. The resultant amplitude of double slit is calculated by cosine law of addition as follows, that is equal to, from this triangle OZ is equal to A sin alpha by alpha and GH is equal to A sin alpha alpha, and OH is equal to our resultant amplitude, that is equal to OH square. From this triangle OH square is equal to OZ square plus GH square plus 2 OG into GH into cos delta. Now OH is equal to R square, that is equal to R square is equal to A sin alpha square by alpha plus A sin alpha square by alpha plus 2 A sin alpha by alpha into alpha, that is into cos delta. Now R square is equal to this one, A sin alpha square by alpha 2 times is repeated, then 2 into A sin alpha square by alpha plus this one also A sin alpha whole square by alpha square. Then we have to take the common 2A sin alpha square by alpha, that is equal into 1 plus cos delta, that is equal to 2 sin alpha square by alpha into 2 cos square delta by 2. Now intensity I is equal to R square, then we can write this above equation is equal to 4 A sin alpha square by alpha cos square beta. Position of maxima and minima. The intensity distribution is of the form of I is equal to R square, that is equal to 4 A sin alpha square by alpha cos square beta. Therefore, the intensity distribution is the product of two terms, these two terms. The first term represents the diffraction pattern produced by a single slit with the width of B, and the second term represents the intensity interference pattern produced by 2 point sources separated by a distance d. Here case 1, minima condition, the intensity is 0 when beta is equal to pi m and m is equal to plus or minus 1, plus or minus 2, plus or minus 3 and so on. Substituting the value of beta, then we will get m pi is equal to pi b sin theta by lambda, that is equal to, here pi cancel and b sin theta is equal to m lambda, or gamma is equal to pi by 2, 3 pi by 2, 5 pi by 2, so on, and we can write it like this, 2n plus 1 pi by 2, where n is equal to 0, 1, 2, 3. Then n pi is equal to pi d sin theta by lambda, and we can write it d sin theta is equal to n plus 1 by 2 lambda. These are the conditions for minimum intensity. And case 2, maximum condition, when beta is equal to 0, sin beta by beta is equal to 1, therefore I is equal to I naught from this equation, which corresponding to the maximum intensity is also called central maxima. The maximum intensity condition of diffraction is tan beta is equal to beta. The interference maxima occur when gamma is equal to 0, pi, 2 pi, 3 pi and so on. We can write it like n pi. Therefore, n pi is equal to pi d sin theta by lambda, or d sin theta is equal to n lambda. This is the intensity distribution due to the double slit diffraction. From this equation, I is equal to r square, that is equal to 4 a sin alpha square by alpha cos square beta. From that equation, a sin alpha square by alpha is due to the diffraction and cos square beta is due to the interference. We can see the intensity distribution due to the interference, these lines, and this red color one is the intensity distribution due to the diffraction. What is the main difference between the single slit diffraction and double slit diffraction? In single slit diffraction, the distance between the maxima and minima will decrease if increase the if you go from the central maxima. In case of double slit experiment, the distance will be constant between the maxima or minima positions.